So today we're working on another CodingBat problem called array2 is everywhere. So we'll say that a value is everywhere in an array if for every pair of adjacent elements in the array, at least one of the pair is that value. So in other words, if you have a pair of elements, at least one of those must be the value specified by the signature or the method signature. And so what we'll do is, so intuitively, we'll say, okay, what we could think, and then we'll sort of negate that assumption to actually tell us why we may not want to take that route. So we'll obviously use a for loop, right, to iterate through the, or as they call it, to traverse the array. And let's see here. So while we're doing this, if, of course, nums of I is equal to the value, or let's say nums of I plus 1 is equal to the value, then what we'll do is we'll essentially we'll return true, right? And of course, if that's not the case, then we'll just return false. Now, this seems pretty intuitive, like, okay, well, if nums of I is the value or nums of I plus 1 is the value, this is kind of, it's like a toss-up, right? It could be either or. Will return true. So if nums of I, if value is nums of I or value is nums of I plus 1, we'll return true. Otherwise, we'll return false at the end. You'd think that this could be the answer. And of course, if you run it, you'll probably get a couple greens here and there. But the first thing that's readily apparent is that we have an index out of bounds error. And that's because we're actually referencing an element by incrementing by 1, the index that is. And we're not taking into account that we could be at the edge of the array. And so by doing this, we mitigate the array index out of bounds error, but we actually don't mitigate all those other reds. So what's the problem? Well, let's pick up an example from here, right? So here we have an example. We have 1, 2, 1, 3. So essentially you look at this, you're like, okay, we should be returning true. Or in other words, we should be returning false because the value specified is 2. And of course, between these adjacent elements, this pair here, we do have a 2, but in this pair, we don't have a 2. However, we are in fact returning true. So why is this the case? Well, if you come inside the for loop here, you'll see, okay, if it comes here, it says, okay, if nums of I is equal to value, which it is, and then if nums of I plus 1 is equal to value, or rather if nums of I is equal to value, which it's not, or if nums of I plus 1 is equal to value, which it is, we return true, okay? And that's just the end of the program. As soon as we return true, it's the end of the program. So it becomes problematic because we're not actually looking at every other adjacent pair. We just find one and we return true. That's not what we want to do. We want to be able to look at those pairs which come after an adjacent pair. Just because we find a pair which sort of satisfies the condition for this particular problem doesn't mean that there isn't a pair later on which doesn't. So what we can do instead is we can say, okay, if nums of I does not equal the value, okay, and nums of I plus 1 does not equal the value, then we'll return false. Okay, let's see, nums of I does not equal the value. So if it doesn't, let's see here. We'll return false here. So if nums of I does not equal to the value, or nums of I plus 1 does not equal the value, we'll return false. Otherwise, if of course it's not falsified, then it must be that we went through the entire array and not once did we find an instance where nums I was not equal to the value and nums I plus 1 was not equal to the value. So that means if we do come out of this for loop, then every pair had at least one nums of I, either it be nums of I or nums of I plus 1, which was in fact equal to the value, and so we'll return true. And you'll see when we run this, we actually get all greens. So the purpose of this is to really show us that if we're looking through the array, and we actually want to look at values, which we want to look at each and every element or each and every pair, we really want to make sure that we're looking at all of them, and we're not just returning true and then just ending the program. We want to be able to look at the rest of the array. So negating the equal sign is a really good one here. We'll say, okay, if nums of I doesn't equal to the value, and nums of I plus 1 doesn't equal to the value, then we'll return false. But of course, we want to go through the entire array. The thing with these returns is that as soon as you return something, the program ends. So if, of course, we never had an opportunity to return false, that means not one pair was not equal to value and nums of I plus 1 was not equal to value. So for the lack of a better word, if the program did not get an opportunity to come inside this bracket, that means that every single pair had, whether every single pair either had a nums of I, which was value, or nums of I plus 1, which was value. And then, of course, after it was all said and done, we returned true.